Hi, in this video here we are going to discuss how to find the inverse of a 2 by 2 matrix. Now, the inverse of a 2 by 2 matrix, what do I mean by that? I mean the multiplicative inverse. Now let's remember what multiplicative inverse was. If I want to find the multiplicative inverse of a number like 3, the multiplicative inverse of 3 is the number that I can multiply by 3 and get an identity, which is 1 in this case. So it's going to be 1 over 3. 1 over 3 is the multiplicative inverse of 3, because when I multiply it by 3, the answer is 1. So when we say we're going to find the inverse of a matrix, I'm talking about its multiplicative inverse, which would be very useful in case we want to solve equations, and we're going to see that in the future. Now, to find the multiplicative inverse, we're going to start by finding the determinant of this matrix. Determinant of A, as we have discussed before, is equal to 4 times 2, which is 8. And we're going to subtract from that the other diagonal, which is negative 1 times 8, and that's a negative 8. And together they make the 16. Now, I'm going to use this 16 to be able to find the inverse of this matrix. Now, we refer to an inverse matrix by A to the power of negative 1. This A to the power of negative 1 is read as inverse of A. We find it by multiplying 1 over the determinant of A by a similar matrix, like something that looks a little like it, but with some changes. The changes we're going to make are as follows. I am going to look at these first two numbers I have here, and I'm going to switch their places. So I'm going to put the 2 in the first row and first column, and put the 4 in the second row, second column. This is for these two first numbers. What about the other two? For the other two numbers, we're going to switch the signs, the negative 1 and the 8. So this is a negative 1, when you switch its sign, it becomes a 1, and the 8, when you switch its sign, becomes a negative 8. We said we're going to multiply this matrix that we have just made by 1 over the determinant. We already found our determinant to be 16. So I'm going to erase that here and put 16. And then we start multiplying. So 1 over 16 by this matrix is going to be 1 over 16 times 2, which is 1 over 8. Then 1 over 16 times 1, and that's 1 over 16. Then 1 over 16 times negative 8, and that's negative half. And 1 over 16 times 4, that's 1 over 4. The matrix we found here is the inverse of A, which means if I multiply it by A, because it's multiplicative inverse, we should get an identity. So let's check if that's true. Now, this is how you check if your answer is correct or not. So I'm going to check by multiplying A by the inverse of A. Now, A here is 4, negative 1, 8, and 2. And I'm going to multiply that by its inverse, which is 1 over 8, 1 over 16, negative half, and 1 over 4. We use our method of multiplication. First row by first column as usual. So I have 4 times 1 over 8, which is a half, plus negative 1 times negative half, which is another half. Together they make 1. Then second row by first column, 8 times 1 over 8, which is a 1, plus 2 times negative half, which is a negative 1, and the sum here is 0. Now I'm going to find the second column, as we usually do. Row 1, which is 4 and negative 1, by second column. 4 times 1 over 16, which is 1 over 4, plus negative 1 times 1 over 4, which is a negative 1 over 4, so the sum is 0. And the second row, 8 by the second column, 8 times 1 over 16, which is a half, plus 2 times 1 over 4, which is another half, and here we get 1. My result is the identity matrix, so now I know that the inverse matrix we found is correct. Thank you.